All right, let's try it 1.24 where we're told to graph this function and then use the extrema to determine the intervals on which the function is increasing and decreasing. Okay, so to graph this thing, I'll pull out a graphing calculator. Here's my graphing calculator. Note that I already have a graph in here. This was the previous example I did, but I went up and turned it off. If you hit enter on the equal sign, now this is highlighted, meaning it will graph it. So if you go back to that equal sign and hit enter, now it's not highlighted, so it won't graph it. So I can leave that in there in case I want to refer back to that later and put in another function, and it'll only graph this second one. Once I start typing in this function, the equal sign will get highlighted. So I want x cubed, x is this button up here. To cube it, I'll just raise it to the third power. And then from that, I want to subtract 6x squared. And note, I don't have to worry about any parentheses here because exponents come before this subtraction. This is x cubed minus 6. Looks like the x didn't hit. Minus 6x squared minus 15x plus 20. And you can try just graphing this thing, but what you'll see is it's not really satisfying. You hit graph, it's thinking, it's drawing. Whoa, there's a line, there's another line, there's another line. Hard to really see the graph with the way it's zoomed. So you got lots of options in terms of what you do now. You can go into the window, this button, and specify what you want your x and y values to be. You can also use the zoom key, and there's a lot of different options here as well. You could zoom in, which wouldn't help, but you could zoom out, that might help. You can zoom a lot of different ways. The one that's kind of nice is this zoom fit. And I shouldn't even say it's nice. Sometimes it's nice, sometimes it's not. This is your calculator's best guess on what you're probably looking at. So I'll hit this zoom fit and see what comes out. And I guess that's pretty good. I don't know. I'm still not super happy with this because it's a little bit hard to see the behavior in here. I happen to know that since this is a third degree polynomial, it can only change directions twice. So I have a maximum here and a minimum here. And even though this is a little bit hard to see, I know how this looks. But you're not supposed to know all that at this point in this class. So you might want a better look. So at this point, you might go into the window and be like, all right, my x's are going from negative 10 to 10. That's fine. But my y is going from negative 1400 to 200. How about I make those, I don't know, negative 200 up to 200. See what that looks like. Then I graph it and wait a minute because I'm so patient. And then I get this graph right here. How do you, the reader, know that this graph continues going down forever? How do you know that it doesn't turn around and head back up here? Well, actually, you'll learn that later on in this book. I think it's section 3, chapter 3, when you start getting into that. It has to do with the degree of this polynomial. It has to do with this little 3 up here. That's why that's true. But you're not expected to know that at this point. So all you can do at this point, I guess, is zoom way the hell out and convince yourself that it really does go down forever. And then when you're convinced that it goes down forever, then zoom back in and be like, this is really the only important parts of the graph. So I have something that sort of looks like this. I guess I can, well, I'll just use this picture. I want to know what this point is right here. And really, since I'm being asked where the function is increasing and decreasing, and anytime you're asked where a function is increasing and decreasing, you specify the x values. I really want to know what's the x coordinate of the maximum here and what's the x coordinate of the minimum here. And the way I can do those is by going into my calc menu. And for the minimum, I'll go down to 3 or just hit the number 3 here. And I'll have to give it a left bound. So I'm going to pick some point over here that's to the left of this minimum. And then my right bound, I'll pick some point, whatever the hell I want, that's to the right of this minimum. And then I'll take a guess at where the minimum is. I don't know, somewhere in there. And I'll hit enter. My calculator will think for a minute. And it'll spit out an x coordinate of 5.00031. I know that that is rounding error because I know stuff that you don't need to know at this point, that this really happens at 5, not at some number really, really close to 5. If you did this analysis again and maybe you picked the endpoints a little bit closer, you zoomed in a little, you could probably get your calculator to tell you exactly 5. I'm going to assume that this is 5. So I'm going to say I have a minimum at x equals 5. And note, I don't even care about the y coordinate because it didn't ask me what's the highest or lowest this graph ever gets. It just wants to know where it's increasing and decreasing. And implied in those questions is on what x intervals is it increasing and decreasing. I'm going to do something similar, except now I'm going to find a maximum. So I'm going to hit 4 here, give it a point to the left of this little hilltop over here. Slowly. There it is. And then give it to a point to the right of this little hilltop here. So I don't know, maybe in here. And then take a guess of where the little hilltop is. And the precision here isn't super important. Your calculator will then hone in on the point. And again, note it's very, very close to an integer value. You might guess that this isn't really negative 0.9999989. It's negative 1. So you got a max at x equals negative 1. Again, I'm not concerning myself with the y coordinate. Doesn't matter. So it's increasing kind of all on here from negative infinity, as far left as I want, up to this x coordinate, which I already said was negative 1. And then it's increasing again from this x coordinate, which I said was 5, all the way to the right, all the way to infinity. So if it asks me where am I increasing, I would say is increasing from negative infinity all the way up to negative 1. And again from 5 up to infinity. And it's decreasing kind of in between there. I'll write my answer and then talk about why my answer is my answer. It's decreasing from negative 1 to 5. Negative 1 to 5 is this point to this point where it's kind of going down here. And you can use your definitions of local minimum and local maximum and how those relate with increasing and decreasing to confirm all these answers. But again, my advice to you, and I hope I don't make any teachers angry with this, is to understand things intuitively. Understand what increasing, decreasing, minimum, maximum mean. And then when you get there, once you got that down, that's kind of your main learning objective of this section. Then go back and look at the definitions and understand how those definitions really do correspond with your intuitive understanding of these concepts. But at any rate, these would be my answers, so I'll stop this one here.